Hello everyone, so in this problem we have the surface integral of 3 times x plus y to the power of 6 times dA. And this area is defined by these two equations. The first equation is x plus y is equivalent to positive or negative 1. And the second equation is 3x plus y is equivalent to positive or negative 1. Now, because these two equations looks quite cumbersome, I want to change the coordinate system. We want u as x plus y and v as 3x plus y. So we see that v minus u is equivalent to 2x and 3u minus v is equivalent to 2y. So x is equivalent to v minus u divided by 2 and y is equivalent to 3u minus v divided by 2. And for changing the coordinate system, we all have to come up with a Jacobian. And the Jacobian is defined as the matrix partial x over partial u, partial y over partial u, and partial x over partial v, and partial y over partial v. So what is partial x over partial u? It is negative 1/2. And what is partial y over partial u? It is 3 over 2. And what is partial x over partial v? It is 1/2. And lastly, partial y over partial v is negative 1/2. So the Jacobian is 1/4 minus 3 over 4. So it is just 1/2. And remember that we have to put an absolute value on the answer of this equation. So, well, anyways, the Jacobian is just 1/2. So the resulting integral can be written as, well, u is from negative 1 to 1, and v is also from negative 1 to 1, and 3x plus y is equivalent to v. So this can be written as v to the power of 6 times the Jacobian, which is 1/2, times du times dv. U is from negative 1 to 1, and v is also from negative 1 to 1. So after putting it in, we can see that, well, u becomes from negative 1 to 1, so it cancels out the 1/2. So it becomes the integral of v to the power of 6 times dv, and v is from negative 1 to 1. So the answer is just 1 over 7 times v to the 7th, and v is from negative 1 to 1. So the answer is just 2 over 7, and that is the answer to this problem.